Yeah, okay. Hello, everyone. Welcome to our last Iron Maiden's perspective programming lesson. So hopefully you've watched all the previous ones before this one. Mainly the intro to robot code one will probably be the most important for you to watch to kind of understand what's going on in this lesson. But today we're going to talk specifically about the drivetrain. So we're going to go into what that means and how to use it and how we code for it, stuff like that. Okay, so just a quick recap. So last lesson we talked about like the different parts of the robot. So we talked about the RoboRio, which we defined as the brain of the robot. It's basically we deploy and build our code through the RoboRio, and that kind of connects it to the robot itself. Joysticks, which control the robot, speed controllers, which control motors itself and the speed of the motor. We can set the speed of the motor through the speed controller. We also talked about solenoids, which control pistons, and encoders, which measure the distance that the robot has traveled, and commands. So here the APIs have all been linked, but mainly if you kind of forgot what each of these mean, just go back to the intro to robot code video and then come back to this one. Okay, so first we're going to talk about tank drive, or first we're going to define drivetrains. So drivetrain is a system of motors and wheels that allow the robot to move. Right, so our drivetrain includes motors, encoders. So these are the two main parts that we use. We also use joysticks and gyros. It also includes the methods, drive teleop, turn degrees, and drive auton, and certain commands. Right, so our drivetrain, we write it in a class, right? So we call this is an example of a subsystem. And we kind of like write everything in the drivetrain class. So all of this stuff is in the drivetrain class, and then our commands are in a different class. But the commands use the methods that we write in our drivetrain. So there are a lot of different types of drivetrains. Probably the main ones that we talk about in our team are tank drive, swerve drive, and mechanism drive. So we primarily use tank drive just because it's simple and it's easy to program. At least for us, and it's kind of easy for everyone to understand, easy for engineering to build. So it's kind of like a good basis to start with. There's also swerve drive and mechanism drive. So swerve drive is kind of great. Like we talk about it very highly on our team because it allows the robot to maneuver really easily. As you can see from this GIF, the wheels kind of are able to turn 360, which kind of allows it to move around better. So as I said before, it's pretty simple, which means engineering can build it, and we can kind of make this all in a timely fashion, and it works for almost all games. So tank drive. Okay, so the overview, 6 to 8 wheels usually. The left and right sides are controlled independently, meaning like we code for the left side and then we code for the right side. All the wheels on one side move together. So you would code for everything on the left side specifically, and then everything on the right side specifically, not like individual wheels on each side. Okay, so now we're going to move into how to code a tank
drive. Okay, so the first part is to import everything that we need from all the APIs that we talked about before. So the first one is our joystick, because like when we want to move the robot, we want to use like the joysticks to be able to control like where it's going and how fast it's going. The second one is a CAN SparkMax, which is going to control the motors directly. The second one is CAN encoders, which will help us like determine the distance that the robot drove. And it's something that we might need later on. The next one is the motor type, which we'll talk about more later, but it'll go into the instantiation of the SparkMax, and then we'll need a gyro. So a gyro, if you guys don't know, is like something that can help us measure like the angle that the robot is facing. So it's basically a sensor similar to the encoder. It just measures the angle that the robot's at. Next slide. Okay, so instantiation. So remember that instantiation is just to create a new instance of a class. So the classes that we need are basically the things that we just imported. So the very good thing about APIs is that like it's just code written like somewhere else that we can just use. So the things we need to instantiate are our joysticks, our motors, our encoders, and our gyros. So you don't have to worry about what an OI is, but just know that you don't have to know what it is right now, but just know that motors, encoders, and gyros will be in the drivetrain. And as you can see in the green box there, I kind of defined it before, but gyro just measures how much the robot has rotated. So the instantiation part. So you can try to do this on your own using the APIs that we had like last week. You can just try to instantiate one of each, a CAN SparkMax, CAN encoder, joystick, and a gyro. So just take a minute to do that, and then we'll show the answers in a bit. Okay, so here are the answers. So for our motors, we usually have 6. So we have like front right, left, rear right and left, and middle right left. So that's what we call our SparkMaxes. And you don't have to worry too much about the parameters that we put in, but we have like another class called robot map where we just store all the ports, so we don't have to like hard code them in this code. But basically just know that robot map dot like something something port are basically just the ports that we set. They're just an integer, and then the motor type dot k brushless will be the same for all our CAN SparkMaxes because of just like the types of motors that we use. So just make sure that you guys have all that. And then the encoders, remember that we're not instantiating the same way as we did like with motors, because encoders are built into the motors. So all we have to do is like get encoder. But you guys can do this, but in our code, we usually just like take one from the left and take one from the right instead of doing it for like all of them. And then joysticks, it's basically the same thing as what you do. And then gyro is the same thing as well. Also robot map that like joy port and gyro port are just like port numbers that we have. Yeah. So tank drive methods.
Yeah, so now we're going to talk specifically about the methods. So we're essentially using the parts that we just instantiated before, and now we're going to apply them to make our methods. So first, you kind of need to know the structure of the game, right? So in the game, there's kind of 3 parts, but the 2 parts in the beginning are autonomous and teleop, right? So autonomous basically means that you're coding the robot separately, and it's kind of like driving on its own. So it's like moving autonomously, essentially. So it's not being controlled by the controller. It's being controlled by a set of commands, which we write, which I think we'll discuss about later. And then drive teleop basically means that the driver has a controller in their hand, and they're specifically controlling the robot with the controller, right? So auton, we kind of need to code for it beforehand, but teleop, it's based on controller input and output. So first, we kind of make a method called drive teleop, and essentially what this is that it's coding for when the driver specifically is controlling the robot in live time, right? So first we need to define left joy and right joy. Essentially, so we're going to refer to these again as thumbsticks. The joysticks itself are thumbsticks, and then the entire controller itself is called a joystick, right? So we need to define left joy and right joy. And essentially what this is that you're kind of telling the code which thumbstick is the left one and which thumbstick is the right one, right? So that's our first step, right? That's what you can see up here. That's the code over here, right? So left joy and right joy. So left joy is essentially saying that this is the thumbstick that we're going to get for the left input, and then this is the thumbstick that we're going to get for the right input, right? So after we've set each joystick to a variable, this is going to represent the speed, right? So it's kind of saying like if the driver moves the left joystick all the way up, it's going to get negative 1.0 as its speed, right? And if it moves down, all the way down, it's going to get positive 1.0. And you know that because this is kind of negated, but oy.joy.getRawAxis basically stands for this value, wherever this is on the like up or down. So after you have these speeds, right, you're going to set them to our motors or speed controllers, right? So we learned about this dot set method last week. Essentially what it's doing is that you're calling dot set on a specific CAN spark max, right? And what this does is that it takes a speed and then it kind of sets the motor to that speed, right? So here we're setting all the right wheels to move at a certain speed, and then you're setting all the left wheels or the left motors to move at a certain speed, right? So look how you see that you're setting the left side of the robot or the left motors to move at the speed of the left joystick and the right to move at the speed of the right joystick. Right, so here we have a question that asks, based on that picture of the controller in the code, what do 0 and 5 refer to? Right, so what do these numbers in here refer to? You can pause the video real quickly, answer in your head, then we're going to go over the answer right now. So 0 and 5 essentially stand for these buttons, these thumbsticks, right? So remember how last time we mentioned that each controller has like its own button map, essentially, right? Each button stands for a certain number. So in this case, we're going to pretend that the left thumbstick stands for position 0, and then the right stands for position 5, right? That's why we're setting it here, right? You're telling it to get the raw axis or the value of this thumbstick here, and then the right joy is asking to get the value of the right thumbstick here. And joy is essentially referring to our controller. If we go back here, you can kind of see that we named it as joy. That's what it's kind of referring to. Okay, so that's our drive teleop method. And now we're going to move into a slightly more complicated one called turn degrees, right? And this is kind of an overview of the turn degrees method, just for you to see like how it looks like. Notice how we're taking angles, right? So essentially what this turn degrees method is doing is that it's allowing the robot to turn, or helping the robot turn, right? And we use this in Auton rather than teleop because in Auton we kind of need to set the robot to move to turn at a specific angle before the competition even starts, right? But in teleop, we can kind of just move it based on what the driver is actually doing with their controller. All right, so first, the logic of this method is kind of difficult. So we've had a few diagrams to help you out, right? So if our angle, so notice how, I'm gonna go back real quick. Notice how the first thing that we're taking is the angle, right? And this angle is basically the angle that you want the robot to be facing. Right, so let's say if the axis is going to start at 0. So if the robot is facing all the way forward or all the way straight, that their axis kind of starts on 0. Let's say they want to turn to 135, right? They're going to turn right. That's what essentially the robot is doing. You want it to kind of rotate itself right, and if we enter 135 as the angle. But if we enter like 300 as the angle instead, you want the robot to turn left. Right, and we do this because it kind of like allows us to have the robot turn faster, right? Let's say we wanted the robot to turn 300 degrees, right? We want it to like its axis or its kind of like angle to be 300. The robot would have to, and it only moved in one direction, the robot would have to turn all the way this way. And notice how it takes so much longer compared to if it were just turning this way. So that's kind of what we do in our code, right? The first part, which is this part over here, we kind of negate the angle if it's greater than 180. And what that is doing is that it's telling the robot to turn the other way it's telling the robot to turn counterclockwise instead of clockwise, right? For instance, we can test it with 300 instead, right? So if 300 is greater than 180, which it is, then you want to set the angle as 360 minus angle, and then you want to negate that. Right, so you're going to say negative 360 minus 300, which is negative 60, right? So this is saying, this is telling the robot to turn negative 60 degrees, which negative means counterclockwise, so that it reaches 300 faster than if it were to move 300 degrees clockwise, right? So kind of like envision it in your head. It's faster for the robot to turn less degrees in a different direction than more degrees in the opposite direction. Yeah, so if you kind of don't understand this, just kind of look at it a little more clearly. I mean, not clearly, but a little longer, and hopefully you'll understand. I'm going to clear these drawings, and then I'm going to move on. So here I kind of have a little better of an illustration. So I kind of explained all this stuff. If it's greater than 180, then you want to save time by turning the opposite way. So again, if you want to, let's say you want the robot to be facing this direction, you want it to move counterclockwise instead of clockwise. And I showed you kind of like how we test this math, and you can kind of see how it works. Okay, so we want the robot to continue to turn until the angle of the robot equals the desired angle. Right, so let's say the robot is facing the 12 o'clock direction and it wants to face 8 o'clock, right? We can kind of do that with a while loop, right? So you can see here, this is the start. And we're gonna say while this robot is not facing a certain number of degrees, then you want it to keep going. But once it has, it's gonna stop at 8, right? So if the angle is less than the desired angle, then you wanna turn right, which is essentially the logic, right? So we can kind of set this as like -30 maybe, right? And this is the angle we are right now. So if the angle is less than the desired angle, then you want to turn right. I think this is backwards. I think you want to turn left for here and then right for here. But kind of like better logic would just to think about it, kind of which way do you want it to turn based on the number of the angle. So if it's greater than 180, then you want to negate and then subtract that angle from 360. But if it's less than 180, then it can just turn in the same direction that it was always going to go, clockwise. Okay, so this is a little same slide that I showed before, right? So the first step is changing the angle to make it less than 180 if it's greater, right? So you're making sure that it's turning in the most efficient way possible. And then we move into this while loop, right? What essentially this while loop is saying is that you want to get the angle of the current angle of the robot is while the current angle of the robot is not equal to the angle that it wants to be facing, then you're going to carry this out. And what this is doing essentially is that it's changing the speed of the wheel so that it turns, right? So if we like set the front right wheels as negative, so you want to set the right side as negative 0.5 and you set the left side as positive 0.5, then it's going to turn left, right? Because you're setting the negative wheels, that means it's going backwards and the positive wheels are going forward. So if you kind of picture in your head, right? If the right side, I kind of mixed up my left and rights, right? So the right side is moving negative, the left side is moving positive. So if you kind of envision it, the left side is moving faster, which kind of like forces the robot to turn, right? If the left side is moving faster, it's kind of gonna overtake the right side, and the right side is like spinning backwards, then it's kind of like moving in that direction. Yeah, that's kind of like difficult to explain, but just like think about it and think about how the wheels are turning specifically. Yeah, so this is basically just dictating the direction. So clockwise or counterclockwise, left or right, stuff like that. So if we want the robot to turn 185 degrees clockwise, clockwise or to the right, how many degrees does the robot turn left, right? Notice how, I'll give you a few minutes to answer this question or pause the video. And then I'm going to go over it right now. Yeah, so if the robot wanted to turn 185 degrees, we don't want it to turn to the right. We don't want it to turn clockwise because 185 is greater than 180, right? So essentially, if it were turning counterclockwise, it would be a faster rotation by like just a few, like probably milliseconds. But you're still moving in the other direction because you want it to go a little bit faster because like timing matters a lot. So instead, we would want the robot to turn 300, it's like 175 degrees counterclockwise, right? And we know that because you're essentially saying negative 175 degrees, so you're essentially saying 360 minus 185, which is probably negative 175. Yeah, because you want it to turn this way, right? So the robot is kind of wants to be facing this direction, right? So you know that going counterclockwise is faster than going clockwise by just like a little bit, 5 degrees difference. Okay, cool. So hopefully that makes sense on logic. It takes a little bit of time to understand, but hopefully if you just like kind of think about it, let it mull over in your head, and hopefully you'll get it. If you have any questions, feel free to ask. Okay, and now we're going to move into drive auton. So remember how auton, I kind of described itself it before where the robot drives itself. We need to do that. We kind of say drive auton and we set the motor speeds to each side of the robot. So essentially, we are just setting the speeds, and it's kind of going to control itself when we call the method or call the command. So this is kind of similar to the drive teleop method, except it's a little simpler. All we need to do is enter 2 speeds as a parameter. So the right speed would stand for how we're going to change the right motors, and the left speed will stand for how we're going to change the left motors. So you can see here that we're setting everything on the right to the right speed and everything on the left to the left speed. And then we're going to print this to the smart dashboard, which is kind of like a display to show us what's happening with the robot. We're going to print this out. But the main part is this part here. We implement the smart dashboard kind of later in our code. Okay, so now we're going to talk about fans.
So yeah, we're after writing all those methods in the class, we have to actually be able to use those methods and use the stuff that we wrote in the class by writing commands. So you might ask, like, why do we need commands if we have everything in our subsystem? The reason for that is because we can't like bind or set a method to we can't set a button to a method. So we can't kind of like press the button and like run the method. It kind of just like doesn't work, and it doesn't work with the subsystem either. So we have to write a command to be able to execute these actions. So the actions that we want to execute are drive teleop, drive auton, and turn degrees. So like if you press a button, you want to be able to like turn how many degrees or like travel some distance or something like that. So with these simple commands, all we have to do is call the method in the command, since we basically do have everything in our subsystem. So let's look at the structure of the command. So just know that a command is also a class. So we do need things like fields and constructors. And just notice the extends command, which is like basically why it's a little bit different. So we need fields, I said, and then we also need a constructor, but there's also a few different parts in a command. So the first part is the initialize. So that's the first thing that runs after the constructor. Like it's the first thing that runs when we call the command basically, and just like sets everything up, like gets everything ready, like gets our variables ready, and things like that. And then after is the execute method, which is run repeatedly until is finished. The next method is finished returns true. So it's kind of like a weird while loop. So basically like while like is finished returns false, then execute will just keep running until is finished returns true, and then it'll stop running. And then when it stops running, then it'll run the end method, which is the final action of the command. Or if like for some reason like something interrupts the program, then it'll just runs the interrupted method. So let's see these in action. So the first part of making a command is importing things. So we will need the commands, robot, drivetrain, because we made that class, and some like other stuff that just know that you need these. We won't explain them too much because we didn't get into them, but yeah, that's what we need for this command. And then each command's constructor needs to say requires robot.drivetrain, because these commands will have to use methods from that subsystem or from that class. So that's why we will like require that subsystem or class. That's basically what that part is saying. The next part will be the drive teleop command. So this command only requires this body and execute. So like when we make a command, there's like usually default values in like the other methods, but we don't need to really change anything except the execute method. And for the execute method, we just need robot.drivetrain.driveTeleop. So it's pretty simple. All we need to do is call the method that we wrote, and that's basically it. And it's not shown, but is finished. That method should return false. All it should say is like return false, because we want this command to just keep running over and over again. like we want to be able to control the robot with our joysticks like almost infinitely throughout the game, basically, until like we shut down the robot or something. And if you're confused about the comments there, you don't really have to worry about them, honestly. Just worry about the thing that's not commented. But basically what this command is doing is just calling that method that Jillian just talked about. Yeah, so the next command will be the drive auton command. So this one will need a little more changing. So these are mainly the parts that we'll be changing. So we need two fields, the left speed and the right speed, and they should be double values. And we'll have to change the constructor a little bit to be able to take in those parameters and set them to the field variables. And of course, we also need requires robot.drivetrain. We actually need that for every command, but this is shown more clearly on this one. And we don't need anything in initialize, which is why that's just like skipped. That should just be like an empty method. And then the next one should be execute, where we basically just call the drive auton command from the drivetrain class. And we just put in our fields that our fields into the parameters, so left speed and right speed. So we could just set the motors to like a certain speed, and you could just print something else, print something out just for like testing reasons to see that it's like working. And then once this whole command ends, you're just gonna set the motors to 0. So like we don't want to like keep running forever at the speed. It wants to be able to like stop somehow. So that's kind of our like stop, basically. And I didn't really mention this, but like it's not really on the slides, but the is finished will probably be like some something that returns a boolean, something like that's a check to make sure that like you're not going infinitely, like you're finishing up this command in some way. But we're just not going to talk about that too much. We'll just know that it exists. So the next one is the term degrees, which all we really have to change is adding a field, which is the angle, because our method needs that parameter. And then we'll have to add that into our constructor as well. So in our constructor, we'll have to get the degree parameter and set that to angle. And we also need the requires thing. That commented out part is actually what we need. So it's not supposed to be commented out, but yeah. And the thing in execute, that also should not be commented out, but nice. Thank you, Jillian. But yeah, so both those parts we actually need. So in the execute, like what we did before, all we have to do is call the turn degrees method and put in our field variable. So it will just turn that certain degrees. And it's also not in this, but the is finished method would return true this time, because after the robot turns, after it executes everything in the turn degrees method that we have, we just want the command to just stop. So in summary, these commands, we write them and they're pretty simple. We just need to call the methods that we wrote in our drivetrain subsystem, in our drivetrain class, so that we can actually like set them to a button, which we'll probably not talk about here, but like if you get on a team, we'll probably like set it to a button so that when you press a button or do something on the joystick, these commands and actions will actually take place on the robot. So yeah, so that's why we need commands. And if this is confusing to you, you don't have to worry about it too much, but we just hope that you understand like the structure of a command and how you might be able to write one. So that should be the end of our meeting.
Yeah.
I don't think there's anything else.
Yeah, real quick, I just want to add, we also use commands for all of our like autonomous code. I think all of it is written through commands. We just have like a list of a bunch of commands. If you watch our video last time, we also talked about like add sequential and add parallel. All of those use commands. That's why we also have these commands too. So they're pretty important. Yeah, that was kind of quicker than I thought it'd be. Yeah, a lot quicker than I thought it'd be. So yeah, like Catherine said, like if you have any questions, feel free to email us or message us. A lot of this stuff is kind of just like extra knowledge. Because when you get on the team, you'll kind of have like head start of all this stuff and how to like piece everything together, which is essentially what we work to do in like your first year on the team. Yeah, Catherine, do you have anything else to say?
Yeah, just like if you're confused, maybe like the first time around, or if we went too fast, just if you're watching the video, just feel free to like slow down or like stop in the middle just to like make sense of things in your mind. But yeah, if you don't understand, you don't have to worry too much because it's not probably going to be tested on like tryouts or anything. This is just like for you to learn and be exposed to these robotics concepts.
Yeah. And we'd be happy to answer any of your questions anytime probably. So yeah, I guess thanks for watching. If you watched our entire like I guess series, thanks for watching it all. We kind of put a lot of work into it, so we hope you learned a lot. If you have any questions about anything, you can email us here. Yeah, or message us on Discord. Yeah, thanks for watching. Have a nice day.